I'm really pleased to be here today to share our research on integrating climate change, water, land use, and sustainable communities. I was asked by Karen to address the interdisciplinary nature of our research, and the way I think about it is to fully understand how communities, both social and ecological, can sustain a secure water supply, and we have to understand the interrelationships between climate change, water, land use, sustainable communities, and in California, especially drought. And this involves really asking questions from not just a social science or a physical science lens, but really trying to integrate the two of them. So my initial focus was water. I see it as central and California's key resource. But it became, as I was looking at water, it became really clear that drought was one of the key issues for California, and I'm a Californiaist in that sense. And that led me to groundwater and to understanding the legal, physical, social, and institutional issues around groundwater. And in some ways, that was my first interdisciplinary collaboration with our own Andy Fisher right here, where he was a hydrogeologist and I was coming at it from the lens of law and institutional perspectives. Well, it turns out that groundwater was managed locally for many, many years in California with not great results. A lot of our groundwater levels declined, we lost our storage, and then we passed the 2015 Sustainable Groundwater Management Act, which required agencies that had particularly depleted basins, what we call overdraft, to now try to bring those basins into a more sustainable position. And at that point, I thought, well, okay, we've got some aspect of thinking about groundwater sustainability, but the next really big step would be how we manage our land with respect to water. And that led me to the next set of projects, which is what we're going to be working on now and what I will talk about, that is really going to be integrating water and land use. We selected we had some great collaborators for that. We selected the Central Coast because it's a really understudied area. Plus, it was an area that I was really familiar with because I had already done some work in this area. And we had collaborators from all different fields. I want to give a shout out to Nathan Van Schmidt, who was actually our postdoc here at UC Santa Cruz, and then went ahead and joined the USGS and did a lot of the excellent modeling and graphics that you're going to see. We've also joined forces more recently with the UC Davis team, and again, a shout out to Ryan Boynton in particular, who's done some of those wonderful modeling and graphics, and Tim Thomas from UC Berkeley. We had a lot of other collaborators in terms of our partners along the coast. So just a quick look at Central Coast. We think of it as a microcosm for the rest of California. The climate is somewhat similar. It's wet in winters, dry in summers, and periodic droughts are the big story, I think. For land use, agriculture is fairly large. Only a few small cities. We were surprised to see that Salinas is the largest city with a population of only about 155,000. The whole area is dominated by natural ecosystems, and there are many endangered species. Demographics are particularly interesting because you have some very wealthy areas along the coast, and of course some rather poor areas inland, and then of course water supply is always a really big problem. That's Lake San Antonio at 9% capacity last year. We also had a lot of interdisciplinary methods, and sometimes that's even the bigger story when you're working with people coming from very different methodologies. We did incorporate a lot of stakeholder engagement all the way through, and I'll talk a little bit more about that. We used a whole range of models. I've shown two here. UPlan is an urban development model. Lucas is a land use land change model. We spent a great deal of time developing what we call our scenarios. So our business as usual scenario basically takes historical trends and then tries to project into the future if nothing changes. But then you can say, well, what if we want to change things? What if we implemented a new strategy or policy? what would that do to those historical projected outcomes. And then for this project, we're also looking at the risk of displacement because we're focusing more on urban development. So historical trends for California in terms of climate, hotter and drier. Precipitation is sometimes a little bit less certain, but even just with hotter and drier, water supplies are going to be challenged. Sorry. So then we looked again at business as usual. Well, what's going to happen? Nothing, we don't do anything. We just follow historical trends. What's going to happen to land use change? And we saw that developed areas increased, that perennial crops increased, and annual crops decreased, and then projected water use followed a similar pattern where you had developed areas and perennial crops, your water use increased, and where you had annual crops, they decreased. And I want to say that both of those models are spatial models. So we not only can get a graph, but we can also see where some of this is happening. Well, this leads us to think about, well, are there some policies we can implement if we want to change some of these trajectories? So for this, we went to our stakeholders as well as to our own core group, and we found that you'll see on the blue side that these were all the water managers, and then on the green side, those were all the land use planners, and those are the suggestions that they gave us. And this was also really interesting because if you think about water and land use, they usually are not talked about together. And we found when we brought these folks together, which we did at the City of Salinas in one of our stakeholder meetings, it was really interesting to get these two perspectives. And you'll see that one of the things that came up was sufficient low and medium income housing, which was the key concern for the City of Salinas because they get their water just from a water provider. So they're not necessarily thinking about, that's the water provider's concern, getting the water. Their concern is housing, and we decided we would try and incorporate that, and you'll see that we do this later on. So then we developed these scenarios. This is usually a really heated discussion amongst all the people because everybody has their own lens and their own ideas. And I'm showing you two of them here. We developed 5 for the first set of runs that we did. And one of them was to limit the water use. So new development spatially, again, this is a spatial model that we use. New development stops if you exceed what we call the total sustainable supply. It was a metric that we developed related to the fact that groundwater was now going to have to be reduced in the future under the Sustainable Groundwater Management Act. And then we also did a limit to urban sprawl as well as a second scenario. And the most interesting, I think, outcome for this, I'm only showing you one out of many, was that if you did not put any water limits on, and you can see in the top graph that essentially overdraft continued, and we called it with current supplies as opposed to people saying, oh, well, yes, we're going to build a desal plant like here in Santa Cruz. And we did actually look at enhanced supplies, but for this we just used current supplies. But if you put water use limits, then that overdraft gets significantly less. And the basins on your left-hand side are essentially the ones that were very overdrafted to begin with. So now we're setting up a new set of scenarios, and we're looking at this relationship between water, groundwater, and housing. And the idea, again, that, we settled on 2 really important acts. Sustainable Groundwater Management Act, which was now law, and Regional Housing Needs Assessment Act, which was now law. And we said, well, are these policies going to really work together? Because when you read about housing in the paper, they never mention water. And when you talk about water, they almost never mention housing. And then we're on top of that, we have our wonderful people at Berkeley that are going to look at, well, what happens when you add in housing to people who might have to move and get displaced. And this is one of the early graphics that we've had. This is the city of Watsonville right here in Santa Cruz. And you can see with the business as usual, you can see that all those reds and yellows and oranges are scattered all around. But RHNA pushes them essentially into the city limits. And let's see, I was going to just say that basically the way we run RHNA scenario in our U-Plan model, it simulates the proportion of expected new population based on census data for each county that a combination of local and state agencies have determined must go inside particular boundaries of the city and the county. as well as into the unincorporated areas. Okay, I just have to add here, though, that one of the things that came up was, what's this going to do to transportation? As we drove into the city of Santa Cruz, because I came from Berkeley, yikes, a lot of transportation here. Will that affect Watsonville? So very quickly, we then, actually prior to doing the housing, we looked at this notion of vulnerability and what does it mean, and we developed the spatial metrics. And again, this is my wonderful postdoc, Nathan Van Schmidt, sort of essentially layered on these various metrics to find out what is it going to do to the overall vulnerability spatially. And here's an example. So for example, you're more vulnerable if you cannot fallow lands in terms of decreasing water supply. You could be more vulnerable if your water costs more. You could be more vulnerable if your habitat is drying out and groundwater-dependent species do not do well. And then again produced a whole range of maps. I'm showing you just one of them, the cumulative vulnerability, which is the sum of all those 9 measures that we talked about. And I'm just looking at it from the perspective of what happens if we use water limits or we don't use water limits. And you can see, again, on your left-hand side, that without water limits, more significant vulnerability if you stack these layers, particularly down in the Salinas Valley, up around Santa Cruz. This gets reduced, and you'll notice the last slide says enhanced supply. That could be possibly your new desal plant, but we didn't find that that necessarily affected things as much as we thought they would. It does a little bit up in the Santa Cruz area that you can see. Our take-home was that strategies to reduce groundwater withdrawals could be really an effective way at reducing groundwater depletion. And also, we didn't talk about it as much for this talk, but strategic placement of croplands at historical rates could achieve sustainability goals. I think we're interested in exploring a few other areas. Transportation just came up on the car ride into Santa Cruz today, but I think, for example, fallowing. What's going to happen when you fallow agricultural land? Well, maybe it's going to help your water supply, but what's it going to do to the farm workers that are working there? And so I think that's, again, where you find this intersection and how you find yourself moving to work with people who can then contribute to this overall picture. That's it.